This video will show you how to design lamp primers using the New England Biolab's Lamp Primer Design tool. To get started, identify the DNA sequence you want to design lamp primers for and select a region of fewer than 2,000 bases to input into the tool. This can be loaded as a text file or pasted directly into the tool using the Paste Sequence feature. As an example, I'm pasting in a region of human BRCA1 gene sequence. Once the sequence is pasted in, click the Process Text button to properly format the sequence text. If desired, give the sequence target a name in the target name box, but this is not required. The Modify Preferences box allows for modification of the design parameters. Lengths, TM, GC content, and many other factors can be adjusted, but for any new sequence, we strongly recommend using the default settings for the first attempt, and that's what we'll do here. After the sequence is pasted and processed, click the Continue box at the bottom of the first screen. The next screen displays the target sequence with the ability to specify fixed locations for targeting with one of the lamp primer regions. This is not common, but if you need a specific sequence to be contained between different primers for a probe or beacon, or a site of variation to be included outside a primer, you can do that here. In most cases, we just click Generate Primers at the bottom to start the algorithm identifying suitable lamp primers. Candidate lamp primer sets are immediately displayed on the next screen with their positions along the target input highlighted in the box at the top. If you can't see the primers, just scroll to the right as they may be spaced far apart on the sequence. Each primer set is laid out in more detail below, with each set of 4 core lamp primers highlighted in tables identified by the corresponding ID number. 8 sequences are displayed, but only 4 of those are the primers: F3, B3, FIP, and BIP. This is because the long inner primers FIP and BIP are composed of 2 distinct target regions, F2 and F1C for FIP, B2 and B1C for BIP. You can see these regions each on the target sequence layout, but they are spaced some distance apart, and the C sections are included in the FIP and BIP primers and are inverted complements, a big reason why using the Lamp Primer Design tool is helpful. Select one of the designed candidate sets to move forward to loop primer design. Ranking of sets is by default delta G of dimer formation. It's very easy to try different sets and data won't be lost, so just pick one to move forward. These generated loop primers are not in the core set of 4 lamp primers from the previous screen and are not required for lamp, but do provide a significant boost to speed and assay performance, and we strongly recommend using them where possible. Click Generate Loop Primers. It is possible that no loop primers can be designed for the candidate core primer set, in which case a No Primer Sets Available box will pop up. If that happens, select the next bubble down and try again. The next screen shows candidate primer sequences identified for the Loop F and Loop B primers. It is possible only one of the 2 will be identified. If only one loop can be designed, that is recommended over using none, but it's worth trying to find a set with both, and in most cases that is possible. In the case that only one primer is identified, we recommend going back to the Core Primers tab or to select another primer set and selecting the next set of core candidates and trying loop design again. Loop primer candidates are displayed in a list at the top, and you'll notice there's a lot of similarity between the options, where up to 10 potential pairs are shown, many with identical loop F sequences and slightly different loop Bs. Choose the top option or one further down the list if you'd like increased GC or another factor. Select the bubble for the loop set you'd like, and then click Get Selected Primers. The final screen will display the full design primer set, adding in the 2 loop primers to the previous 4 core primers on the table. All relevant information and oligo sequences are on the table, with the orange sequences representing the oligonucleotides to order from your desired provider. Information can be copy-pasted, or you can click Download Primer Set, and you'll be provided with a tab-delimited text file directly compatible with batch ordering through the IDT Primer portal. For any new lamp assay, it is advisable to screen more than one candidate primer set to find the best performance in terms of speed, sensitivity, and non-template amplification. From the Results tab, you can either click Select More Primer Sets or the Core Primers tab to go back to the candidate set page and repeat the selection and loop primer design steps. Each set can be downloaded individually for easy ordering, or you can paste all of the design primers into another sheet or form. Just take care to keep each set together, as the names are generic primer IDs and not associated with the set. If you have questions about using the Lamp Primer Design tool or need any other technical support, please visit info@neb.com.